Hi, I'm Dr. Deborah Campbell, and I am making this companion video to Patrick J. Hurley's A Concise Introduction to Logic. Chapter 7 is Natural Deduction in Propositional Logic, and this is a video to go with 7.1, the Rules of Implication, Part 1, and this is a little quick start guide to not only 7.1, but it can be used for all of Chapter 7, sections 7.2, 7.3, and 7.4. It's going to be the same methodology. Each additional section just adds a few more rules, okay, but it's going to be the same method. So let's start with an example. In Chapter 6, you learned about propositional logic and how simple and compound statements are put together to form arguments in propositional logic. And here's a little straightforward argument that I use as an example to introduce this natural deduction. Because you've been doing natural deduction since you became verbal. So at 2.5 years old, you could easily follow natural deductions. And by that I mean deductive reasoning in natural languages like English, French, Spanish, etc. So what is a natural deduction? Well, when my son was 2, I could see that he could follow natural deduction because I could make a claim to him, something like, if you're good, then we'll go to Chuck E. Cheese's. Now you may recall that's a hypothetical or conditional statement with an antecedent and a consequent. If you're good all day, then we'll go to Chuck E. Cheese's tonight. So if he was good all day, then what would he naturally deduce? Well, that he was going to get to go to Chuck E. Cheese's. And you learn in Chapter 6, the symbolic version of that would be G implies C. If you're good, we'll go to Chuck E. Cheese's. You're good all day. Conclusion would be, we'll go to Chuck E. Cheese's. Now, again, any 2-year-old can follow that deductive reasoning. And if you say that if you're good, we'll go to Chuck E. Cheese's, and the child is good all day, and you don't take him to Chuck E. Cheese's, he's going to know that you lied about the first claim, right? That the first claim ended up being false because we make these natural deductions. So in this chapter, which begins with section 7.1, they introduce the first 4 rules of implication, which are the first 4 basic rules in natural deduction. Each rule is a valid argument form that we use constantly, all the time, to express some reasoning in these natural patterns. Instead of thinking of them as a bunch of P's and Q's, as they're illustrated in your book, where they use the small letters P, Q, R, and S as variables to stand for any proposition, but instead of thinking about learning these forms as P's and Q's and R's and S's, it's better to think of these as natural patterns of reasoning that you use all the time and create your own examples that fit those argument forms. So every rule is a valid argument form. And the first one, the most common, which this is an example of, if you're good, we'll go to Chuck E. Cheese's. That's an example of the first rule called modus ponens. It's a Latin phrase. Modus means manner or way. Our word mode comes from that, like a mode of transportation. And ponere means to put or to place. So modus ponens, this is the most common way of making an argument or a natural deduction, and in our case, it's in English. So how does modus ponens, what is that argument form? Well, you should be learning that it starts with a conditional statements. Again, we use the small letters P and Q to just stand for any statements that could be an antecedent and a consequent. So if P implies Q and the antecedent condition is met in the second step of the reasoning, then the consequent Q follows. So the argument form is P implies Q, P is true, Q follows necessarily. All right? Now again, it's not memorizing P's and Q's, it's remembering that the pattern is that you start with any conditional statement, and if the antecedent condition is met, then the consequent follows naturally. Okay, so that's our first valid argument form, the first rule that is introduced in section 7.1. The second rule is modus tollens. It also begins with a conditional statement, P implies Q, and then in the second step, and this is important, you deny the consequent because you said P necessarily leads to Q. So if Q is not the case, remember this would be not Q, then necessarily the antecedent condition was not met. So P implies Q, not Q implies not P. That's modus tollens. Again, modus means manner or way, and tollendere is a verb, Latin verb meaning to take away. So the second premise in this valid argument form takes away the consequent, which means the antecedent condition wasn't met. So remember that you may recall from chapter 6 that this valid argument form is often confused with a fallacy called denying the antecedent. If you have a conditional statement, P implies Q, and then someone says, it's not the case that P, not the antecedent, therefore not the consequent, that's not valid. So don't get that format confused with the invalid form of reasoning called denying the antecedent. That's when the not P and the not Q would be reversed. Okay, so be careful about that one. Hypothetical syllogism is a very easy, valid deductive argument form that you probably recognize. It was presented when they were introducing deductive reasoning in section 1.3 and 1.4. But it goes like this. If some proposition implies one other, P implies Q, and if that consequent Q implies another proposition R, then you know that if you start with P, you can deduce that you're going to end with R. So these two together, P implies Q, Q implies R, would allow you to naturally deduce that P implies R. Okay, so that's our third rule in 7.1. And the fourth is disjunctive syllogism. This particular rule begins with either or reasoning, a disjunctive statement. So if you have an either or, if it's either P or Q, if it is not P, then necessarily Q follows. Okay, so it's an either or, you deny one disjunct, and that thereby proves the other. Now, you may say, well, isn't it also valid that if you said P or Q, not Q, therefore P? That also would be a valid argument form. But that's not disjunctive syllogism. Think of applying these rules as a game. When I demonstrate how to do the proofs, think of this as a game, and the game has rules, and you have to follow the rules carefully. So the rule for DS is if it's either P or Q, and you have the negation of the one on the left, you get to bring down the one on the right. You could reverse that and it would still be valid, but it wouldn't be our rule. Now later on, when we get to 7.3, we're going to have rules of replacement, and we're going to see that you don't need the other form of that rule. Okay? So the rule DS says you have to have the negation of what's on the left, and you bring down the right. Okay. Now, what's important about, again, learning these rules is not memorizing the abstract form of the rule, but internalizing the rules so that you recognize that pattern of reasoning no matter what statement letters are plugged in. So, for example, because these P's and Q's stand for any simple or compound statement, you could have this example where you might see A and B together imply C and D. And here's your main operator. It's an implication. So this would be P, and this could be Q. All right? Now, the P condition A and B is met on line 2. So what would you naturally deduce? Well, the whole thing C and D. And then you would write down from lines 1 and 2, and the rule modus ponens allows you to derive that. So remember that these little variables stand for any simple or compound statement. And when you're trying to apply that rule or the pattern of reasoning, look for the main operator. All right? So this would be P, this whole thing would be Q, this would be P repeated, and you could derive Q. Okay, so that would be an application of modus ponens where you have compound statements. So let me walk you through how you're going to do the exercise sets. Now, in Chapter 7, the very first thing in the module is my written introduction to the chapter. And in that, I give you the information I'm going to give you right now, if you want to go back and read it again. It is an explanation of how the exercise sets in each section of Chapter 7 are divided into 3 parts to help you walk through learning how to do a proof step by step. So the Part 1 exercise sets, they will begin by giving you a couple of premises. These are premises or the givens, and then a blank line. And you're supposed to look at the premises together and see what rule, what pattern would they fit so that you could deduce the next line. So if they give you R and they give you R implies S, the only pattern we have for a conditional statement and the antecedent is the modus ponens rule. And it doesn't matter where these occur in the proof. As long as you have a conditional statement and the antecedent, you get to derive the consequent, and you write down from lines 1 and 2 modus ponens. So in the Part 1 exercises, they give you some lines. They want to know what you can deduce using which rule. Now, the first 4 are always very simple with just 2 lines. But when they get to problem number 5, they start throwing in additional lines to see if you can figure out which 2 lines go together to fit one of the rules exactly. And so don't be thrown by the fact that they throw in additional lines. You just ignore them if they don't help you to fit one of the patterns that helps you deduce the conclusion. Okay, in the Part 2 exercise sets, in this one they give you a line or 2, and then a blank line, and then a conclusion they want you to be able to derive. So if A implies B, and you want to end up with not A, which rule would allow you to do that, and what would you need to be able to accomplish that? This Part 2 exercise is helping you to start looking at your conclusion to prepare you for doing an entire proof. So if A implies B and you want to end up with not A, which rule would help you do that? Well, modus tollens says if you have a conditional statement and you want to end up with the negation of the antecedent, then you would need not B on this line, the negation of the consequent, and then you would derive this from 1 to modus tollens. Okay? Again, when they start throwing in additional lines, don't be thrown by that. Just make sure that you're substituting 2 lines that fit the form exactly. In the Part 3 exercise sets, now you're going to be doing an actual proof or demonstration in natural deduction. You're going to be doing the whole thing. So they start with some givens. In example number 1, they give you 2 lines. And then over to the right, there's a slash mark and what will be the conclusion, what you're aiming to prove. Now, these 2 together are going to help you prove this, but you're going to need to apply some of the rules to get there, right? You're not going to be able to do it in just one step. So, looking at the first 2 lines, and be sure to look at the strategies in your book as well. They say, when you're trying to do a proof, look at the conclusion and look to see where you find that letter in the premises, and then start thinking about your strategy. Well, you're trying to prove not A and you have a not C. You can't get to it directly yet because this is part of a larger expression and it's inside of parentheses, and you can't apply these rules on part of a line. So remembering that, look at what you can do. So if not C implies this and not C is the case, then your next step that you can derive would be A implies C, and that's going to be from 1 to modus ponens. So remember, this whole thing is P, this whole thing is Q. This is the case, you have the antecedent, you get to bring down the consequent. And then in your next step, you can now use that line with any previous line to derive your next step until you get to the conclusion. In this case, you have now on line 3, A implies C, and we already said in line 2, not C is the case. That was already given. So with these 2 together, you should see if if you know the rules well enough, then you should see that you can now derive not A in the very next step, and that's from 2,3 modus tollens. Okay? And once you reach the conclusion, you're done. That's it for the proof. Okay, so that's a little quick start guide to the first 4 rules of inference, or the first 4 rules of implication, and the approach to the exercise sets. It's really 3 different exercises. But all of those are leading you toward doing proofs in natural deduction. Now, 7.2, 7.3, and 7.4, I haven't made videos for those because it's the same method with the same 3 types of exercises. You'll just be adding a few new rules each time. All right? Remember, there are plenty of videos in Chapter 7 that have lots of graphics and walk you through every step of doing a proof. Also in MindTap, there are videos as well. So I hope that was helpful, and thank you very much for listening.